Hello, chemistry class. This will be our last lesson for the week, and we're going over section 2, talking about the concentrations that a solution has. And there's no video of my face today. I don't know if that's good news or bad news, but that's the state we're in. So a concentration is simply just a measure of the amount of solute that is dissolved in a given quantity of solvent. And comparing concentration is subjective. We're just going to compare one solution to another. So a dilute solution is one that is less concentrated than another. The concentration that is, the solution that is more concentrated, we just call it the concentrated one, right? So let's say we have all these different glasses and we're putting like food dye into them or something. So we can express concentration as how much mass in a given volume. So we have 1 gram per liter of red dye and it looks very pale. If we bump that up to 3 grams, it becomes more concentrated and more and more and more, right? So if I compared the 3 and the 6, the 3 is dilute compared to the 6. But if I compare the 1 and the 3, well, the 1 is dilute compared to the 3. So this is all subjective. Now, in this case, everything is equal volume. But if I look at these two glasses on the left, one is 1 gram per liter, the other is 9 grams per liter, but there's way less of it. Now, I can dilute that 9 grams per liter sample because it is, even though there's less water, even though there's less material, it is still more concentrated. And the only way we can really tell in this example is to look at the color. But if I just simply add water to it, I can dilute it to the point where it is identical in every way. So then, rather than the subjective way, how can we compare concentrations numerically? Well, for solutions, we always use the number of moles per liter. It's always the liter. A liter is 1,000 milliliters. So we can always weigh how much solute we have. We just need to compare that mass to the mass on the periodic table. So we'll do an example problem here. Let's find out the concentration of 10 grams of salt mixed with 100 milliliters of water. So we know we have 10 grams of NaCl and 100 milliliters of water. Now you can get a periodic table online. There's also a periodic table in the back of your textbook if you have a book at home. But anyways, the molar mass of sodium chloride is 58.45 grams, right? So first we need to figure out, well, how many moles do we have? Well, we have 10 grams in the problem. We always divide that by the amount on the periodic table. So we have 0.171 moles of salt. That's step 1. Step 2, we always compare to 1 liter. So I don't have 1 liter, so I need to convert this. 1 liter equals 1,000 milliliters. So take the amount we have, 100 divided by 1,000. Well, that's just simply 0.1 liters, right? So we have 1/10 of a liter. Now we just divide these things because it's moles per liter. In other words, moles over liters. So there we go. We have a 1.71 molar concentration of sodium chloride in our example. So here's your first bonus question. This is part of the assignment for this week. If I have a 1.71 moles per liter solution of salt, what would be the mass of the salt if I had 2 liters of the material? Okay, so to calculate the molarity of a solution, we will divide the number of moles of solute by the volume of solution in liters. So here's bonus question number 2. A solution has a volume of 250 milliliters and contains 7/10 of a mole of sodium chloride. What is the molarity? The other thing we can do is we can solve for how many moles a solution contains by multiplying its molar concentration by the number of liters. For example, how many moles does a 2 liter, 2.5 molar solution contain? Well, this is easy. We take 2.5 moles times 2 liters. So in total, there's 5 moles of material here. And here's our third bonus question. How many moles of ammonium nitrate are in 335 milliliters of a 0.425 molar solution of the material. Now, to help you out here, we're going to have to compare 335 milliliters to a liter, right? Also, the fact that it's ammonium nitrate is totally irrelevant. We're not going to be looking at the periodic table to figure out its mass. All we're doing is converting those moles based off of the volume we have. Notice in the example problem we just did, I didn't have to account for molar mass at all, just the amount of moles and the volume of the material. There are questions that guide you through this in your book that show you step by step if my instructions are not clear enough for you. Next, making a dilution. So diluting changes the concentration, but not the amount of solute, because all we're doing is adding water or some other liquid. Let's say I have 100 milliliters of a 1 molar solution. That's its concentration. Well, then I dilute it to 500 milliliters. So I want to know, what is the concentration? Well, first we compare volumes. So in the end, I have 500 milliliters. I started with 100. So in other words, I have 5 times more liquid or solvent at the end than the beginning. So this tells you by what factor you have diluted your concentration. So I take the original concentration, which is 1 mole, and I'm going to divide it by 5 because I'm diluting it. So it is now a 0.2 molar solution. Now, there's actually a formula for this as well. And the formula is the initial molarity multiplied by the initial volume is going to equal the final molarity concentration times the final volume. So we'll do another example problem. What we're solving for is how many milliliters. So we're solving for V1. How many milliliters of a 2 molar solution are needed to prepare a 100 milliliter sample that is 0.4 moles, right? So we're going down in concentration. Well, here we go. There's the formula. Initial molarity times initial volume equals final molarity times final volume. We're solving for V1. So we bring M1 over. You do that by dividing. And then we plug in the numbers from what we were looking at before. So M2 and V2 are always going to be found together. And in this case, it's at the end there, a 100 milliliter sample that is 0.4 moles. So that's what's going on our top. That's our M2 and our V2. And we are going to divide by the initial molarity, which is 2. So I need 20 milliliters of the stuff. All right, bonus question number 4. So I want you to tell me how many milliliters of a solution of a 4 mole concentration are needed to prepare a 250 milliliter sample of 0.76 molarity. You'll set this up exactly the same as the other question. There is one more small section in your book that is on percent mass. I'm glossing over it here because it's a little difficult to write out the way it's done using PowerPoint. There's only one question at the end of section 2 related to this, but percent mass is pretty simple. We've done percent mass before. So read through that, make sure you got it, and you'll do just fine. Have a great week and have a great Easter break.